So today we'll teach you about Chapter 2.3 from our textbook. Graphs are the most effective way to communicate data.
There are different types of graphs. There are line graphs, there are bar graphs, and pictograms, the ones from our textbook. So pictograms are different types of graphs from line graphs and bar graphs. They represent a picture of an animal or things that used to show the data, but sometimes they can be tricky. On a graph, sometimes you can notice there is a trend, which is a long-term trend or a downward trend. It's a trend over a moment of time. And here's an example of a line graphs, and the line graph shows the change over time. And here's an example of an average precipitation. It shows this changes over time during month to month, so that's an example of a line graph. The bar graph. The bar graphs show and compare data. So we have different number of students and number of hours they watch the television. So we can see that different types of students watch how many hours of television. And here's an example of a pictogram. So like we said in the beginning, they show animals or some other type of symbols to represent their data, but sometimes also they can be tricky. The principles of making a good graph. The principles are to make sure that there are labels and legends and keys that tells you where the variables are plotted. Make sure to look for the units and the source of the data. Make sure it's always true. Make sure the data stands out and catch viewers' attentions. We don't want to show you data that is clustered, because it would make confusing to the audience or the viewers, whoever is looking at the data or the graph. And pay attention to what your eye sees, and avoid pictograms and 3D graphs. Remember, you're here to make a graph, not a art thing. And this is a percent of change. This is an example from our textbook. We measure the percent of change to show if the numbers are true or not. So when doing a percent of change, you always start with the starting value, not the smaller value. And we do the percent of change. Like here from an example, we take 15,000, that number, and this number, subtract that, divided by this number, and then times 10 to get the percent. And here's an example, like we said. You always have to ask yourselves if the numbers make sense. You can always look at the data and be satisfied with it, but you have to make sure that it's true or not. And one of the most common way to mislead data is to cite the numbers that tell the whole story. And you can detect suspicious numbers because they don't seem plausible, and you should know by looking at the graph or the data. And here's a summary of Chapter 2.3. Line graphs, again, show changes over time, and bar graphs compare two different types of data. And always be sure to look for an upward or downward trends and any other seasonal variations. Sometimes graphs can always mislead data sometimes, and so you always have to be careful on that. And on line graphs, make sure to see if they've been stretched or squeezed to create a particular impression. They do it for a reason, so that the data makes sense. And look at the data and ask if they make sense, or look for any other important type of information. And also look for inconsistencies, and also check for incorrect arithmetic. And the main aim of statistics is to provide an insight within means of numbers.
The end.